Hello guys, welcome to my channel. Today we are going to start with the instrumentation. In the previous video we studied about the introduction, theory and Beers-Lambert's law. In today's topic we are going to complete the full instrumentation of the UV visible spectroscopy. As you guys know, this instrumentation is very important because this the parts or the instrumentations, like example the detectors or the monochromators are the source of radiation or used in the other instrumentation also. So this instrumentation becomes a very important topic for your learning. So I recommend you not to skip this video and watch the video completely and rewatch it if you did not understand it, and if you did not get the point after rewatch also, then you can just comment it. I will make sure I will make another video where I can explain where you did not understood. Okay guys, let's start with the instrumentation. uh, Firstly, the instrumentation consists of mainly five parts. It consists of the light source, filters, monochromators, sample cell, detectors, and recording devices. These are the five parts. The important parts are the light source, the filters and the monochromators, and the detectors. These are the very important parts, and their selection directly affects the result. Firstly, you can there are mainly two diagrams. I have given you two diagrams. You can draw any of these two diagrams. Both are correct. I prefer this diagram. It is very simple, and you guys can easily draw the diagram. Firstly, the light source, entrance slit, polychromatic light passes through the prism, conversion, dispersion of the white light into VIBGR, then exit slit, the monochromatic light passes through the sample, then detector. This is the simple diagram of the UV visible spectroscopy. Or I can draw this diagram. It is a source. uh, the light, as the light diverges in different directions, the lens, mirror and slit are used to converge the light into a straight line which can pass through the prism or the grafting uh, and the filters, so that the polychromatic light is converted to the monochromatic light. Then the light passes through the samples on the reference, then it passes through the detectors and the readout devices or the recording devices. It is a basic concept. Here, the source is used to provide the light or the radiation at a particular range. Here, the range is UV and visible range 200 to 800 nanometer, and the lenses, mirrors, and slits. These three parts are used to uh, converge the light at a direction. As the light emitted is a different direction, this helps to converge the light into a single direction, and the light is passed through the prism, filters and the grafting. The main function of these three are to convert the polychromatic light into monochromatic light. As it passes then as the light passes to the reference and the sample holder, then it passes through the detector. The absorbed light by the sample is recorded in the readout devices and the recording devices. This is the basic concept of the instrumentation. I think so you have understood, and we will go each and every part. Firstly, the light source. What are the ideal characteristics of the light source? Firstly, we should know that it should be stable, it should not fluctuate, economical, should emit a continuous spectrum, it should be simple in construction and operation. This is the basic ideal properties of any light source. And there are these are like mainly four types. In exam you can explain any one of them. Here there are hydrogen discharge lamp, deuterium lamp, xenon arc lamp and tungsten lamp. These are the main four types. I prefer, my suggestion is that you read all these four, because In IR we use a tungsten lamp. In every other instrument we use one or the other type of the source. So that I recommend you to study all these four types. Then we'll go one by one. I'll explain you all four types. It's there are very these are very simple, and it does not take much time. I'll explain all the four times, but in exam you can write only one. Any one, they'll not ask any particular. You can write the any one. You can list out the types and write any one. The hydrogen discharge lamp. You can see the hydrogen discharge lamp contains, you can add it. Wait 1 minute. Okay, the hydrogen discharge lamp contains pair of electrons, is enclosed in a glass tube filled with hydrogen gas. When the current is passed through these electrodes, maintained at high voltage, discharge of electrons occurs which excite hydrogen molecule, which in turn causes emission of UV radiation in near UV region. It is stable and robust. Robust is nothing but it is strong, steady, and able to withstand difficult conditions. I'll explain you by using a simple diagram, or else you can find the this diagram, hydrogen discharge lamp diagram, in the online, or else I will try to paste the diagram here. If possible, I will edit the diagram in here. Okay, next, see, uh, the concept based in the hydrogen discharge lamp that it contains a pair of electrodes connected to an high voltage battery current supply or voltage current supply. When the high voltage current supply is passed through this electrode, there is a release of electrons from the electrodes. Release of electrons from the electrodes occurs. These electrons excite the hydrogen gas will excite the hydrogen gas, which in turn causes emission of UV radiation. This is the basic concept. Electrons from the electrode releases after the high voltage is applied. Then these electrons will excite the hydrogen atom. The excited hydrogen atom moves from ground state to excited state. As it is unstable in the excited state, it comes back to the ground state by the emission of UV radiation. This is the basic concept. I think so you have understood the like mechanism or the process. See, here the electrodes contain electrons. Due to supplying of high voltage, these electrons are released from the electrode. These electrons these electrons will excite the hydrogen molecule from the ground state to the excited state. I already said what is excited state. Excited state, this excited state is unstable and comes to the ground state by emission of the UV radiation. That's the basic concept. I think so I have understood this. It's very simple. That's the basic concept. See, I already said it contains a pair of electrodes enclosed in the glass tube filled with hydrogen gas. I already said hydrogen gas. The current is passed through the electrodes maintained at high voltage. The discharge of electrons occurs which excite the hydrogen molecule, which in turn causes the emission of UV radiation near UV region. That is the basic concept. I think so you have understood it very easily. Next, xenon arc lamp. A xenon arc lamp is a specialized type of gas discharge lamp. Light produced by passing electricity through ionized xenon gas at high pressure. The wavelength is 200 to 800. This is the same concept. It is also same. Here it contains xenon gas in the place of hydrogen. That is the difference. I think so you have understood. Next, the tungsten, this is the old type of radiation source, but it is very important, as it is used in IR instrumentation. Its construction is similar to the household lamp. Already you have known tungsten were being used in late 90s and 20s. Now we are not using, we have replaced it to LED lights. uh, in homes like the bulb used to be like this, with a tungsten filament in between, with a tungsten filament here. This is the mainly the lamp here. Okay, I think so you have understood what I'm trying to tell. The construction is similar to the household lamp. The bulb contains a filament of tungsten fixed in an evaluated condition and then filled with the inert gases. I think so I've understood. Here the tungsten is placed in an upper position of the bulb and filled with the inert gases. Next, the filament of the tungsten can be heated up to 3000 degrees uh, and this on Kelvin. Beyond that, the tungsten starts sublimation. It is used when polychromatic light is required. The demerits it emits the major portion of its radiation energy in near IR regions of the spectrum. That's the main demerit. I already said it is used in IR instrumentation. Next, the last one, the deuterium lamp. The deuterium lamp, it is similar to the hydrogen discharge lamp. It is also similar to the hydrogen discharge lamp, uh, but filled with the deuterium in the place of hydrogen. Only all the instrumentation, all everything is same, but here we fill the gas. We replace the hydrogen gas with deuterium. That's it. It offers 3 to 5 times more intensity than other types. Deuterium lamp is most expensive than hydrogen lamp, but it is used when higher intensity is required. As its the main advantage is it offers 3 to 5 times more intensity than other types, and as it offers more intensity means it is more expensive. That's These are the 4 types of light sources, light sources: the hydrogen lamp, deuterium lamp, xenon arc lamp, and tungsten lamp. All four are very important because every type of light source used in either of the instrumentation. This video is gonna be a little longer than the previous videos. Next, collimating system. Collimating system is nothing but uh, the radiation emitted by the source is collimated, made parallel to the lens, mirrors, and slits. Already I have said they make the light parallel uh, by passing the light into the lens, mirrors, and slit. Already I said you that these systems, as the light travels at different directions, these systems make the light to travel in a single direction. The lens or the mirror or the slit, these are used to make diverge or collimate the light into a single line, make parallel. This is the basic concept of the collimating system. There are mainly the lenses, mirror, and the slit. The mirror firstly we'll go with the lenses. The materials used for the lens must be transparent to the radiation. Ordinarily, silicate glass transmit between 350 to 3000 nanometer, and it is suitable for visible and near IR regions. Quartz or fused silica is used as a material for lenses to work below 300. This is just ordinary. Just know the lenses, what are the function of the lenses. Next, mirrors. These are used to reflect, focus, and collimate the light beam in the spectrophotometer. To minimize the light loss, mirrors are aluminized on the front surface. Due to prevent the loss of the light, there is addition coating of aluminium. That's it. And the next, the slits. The slits. It is an important device in resolving polychromatic radiation into monochromatic radiation. I think so you have understood. The polychromatic light is converted to monochromatic light. To achieve to achieve this, entrance slits and exit slits are used. Entrance slits where the light is entered, and exit slit where the light is exited are used. The width of the slit plays an important role in resolution of polychromatic light. The width is nothing but the distance between the upper and the lower slit. It plays a very important role in the resolution of the polychromatic radiation. I think so I have understood the concept. Next, monochromators. Monochromators, it is a device used to isolate the radiation of a desired wavelength from the wavelength of the continuous spectrum. I think so. I have little bit understood the sentence. See what the monochromators do, right? There is continuous spectrum of different wavelengths. Monochromators select a particular wavelength. If example it is 1, 2, 3, 4, and 5. Monochromators select a particular wavelength. Example, here we need only UV region. We select UV and visible region. We select only 3 and 4. The monochromators works in such a way that it only transmits the light only at the UV and visible region. This is the main function of the monochromators. It is a device used to isolate the radiation. It is a device used to isolate a particular radiation from a desired wavelength from wavelength of the continuous spectrum. There are many wavelengths, but the monochromators are used to isolate a particular wavelength. That is the main function of the wavelength. And here you can see the parts of the conversion of polychromatic light to the monochromatic light. First, entrance slit, through which the polychromatic radiation enters from the source. Collimating system, it can be either lens or mirror. Next, dispersion device or dispersion element. The dispersion element disperses the heterochromatic radiation into the component wavelength. Next, exit slit allows the numerical wavelength together with a bond of wavelength on the other side of it. It is nothing but the light is emitted. See, this is the like basic diagram how the instrument works. As the source of light travels to the collimating mirror, the mirror is a function is to collimate the light or reflect the light into the grafting, where the polychromatic light is converted into monochromatic light and it passes through the exit slit. This is the basic diagram of the collimating system, or the conversion of how the light is converted to the polychromatic light to the monochromatic light. Next, we are studying the what are the different types of monochromators used. Firstly, filters, prism, and grafting. Filters, prism, and grafting. The filters, there are two types of filters: absorption filter, and next one is interference filter. This video is a bit longer, guys. Please stay on. You'll understand this topic very clearly. First, absorption filter, produced in a variety of host materials like gelatin, liquids, and plastic. Absorption filters can be produced or made up of gelatin, liquids, and plastics. Works by selectively absorption of unwanted radiation and transmission of the radiation which is required. I think so. You understood what is absorption filter. Absorption filter observes the unwanted and transmits the radiation which is required. That is the basic principle or the mechanism. What is the working here? Selection of absorption filter is done according to the following procedure. See, okay, draw a filter wheel. See, draw a filter wheel like this. Write the color. Just a minute, guys. Write the color VIBGR in a clockwise or anti-clockwise VIBJYOR in a clockwise or anti-clockwise direction. Okay, guys. Next, if solution to be analyzed is blue color, if solution is to be blue color, then we take complement color, then we blue in color, a filter having complementary color orange is used to analyze. If the solution is blue color, then orange color we select, and the remaining part all the light is absorbed and only the region in the orange layer it is transmitted. That's the basic mechanism. And absorption of gas filter is made of solid sheet of glass that has colored by the pigment which is dissolved or dispersed on the glass surface. It's just a extra point. It is not related to the mechanism. The basic mechanism is that if the color is blue color, we select the complementary color orange color, and these all the different wavelengths or the different ranges, we just absorb the unwanted radiation and only transmit in the orange color. We just leave this only this column to this column where the light transmits through this is the basic concept. The merits are it is simple in construction, cheap, and selection of the filter is easy. Next we'll see the demerits. As the main demerit is it gives an the particular range. It does not give a particular wavelength. If we want to measure at 400 nanometer, it gives in 370 to 430 nanometer, but we want only 400 nanometer. There is particular range, so that it is less accurate and the major demerit of absorption filter. Next, interference filter works on the interference phenomenon, causes rejection of unwanted wavelength by selective reflection. Here it is based upon the selective reflection. It rejects the unwanted radiation by selective reflection. See, you can see this diagram. We'll just go with the diagram first. We'll understand this sentence. It is uh, constructed by using two parallel glass plates which are silicated internally and separated by a thin film of dielectric material of different reflective index. Example, the dielectric materials are calcium sulfate, uh, silicon oxide, and magnesium fluoride, I think so. The filters have the band pass of 15 to 10 to 15 nanometer with peak transmittancy of 40 to 50%. See, this is the basic diagram. I'll just explain this diagram. You can understand the mechanism involved in it. See, as the light beam passes through the surface A and surface B, it only transmits the wanted radiation. It only transmits the wanted radiation and reflects back the unwanted radiation. They reflect back the unwanted radiation. This is the basic concept. See, the reflection interference gives monochromatic light. Here, the polychromatic light falls on the surface B, and it reflects back the unwanted radiation and transmits only the wanted wavelength. That's the basic concept. Here, A and B are semi transparent silver films, surface A and surface B. This is the basic concept, and these are dielectric layer. I think so. You've understood the concept. Next, we'll go with the next the prism. As everyone know, prism is made up of glass, quartz, or fused silica. Prism are used to disperse UV and visible radiation. See, you can see when a monochromatic light or a white light passes through the prism, the light disperses into VIBGR, 7 colors. You know, as the dispersion of the rainbow occurs, same way here the dispersion occurs of the white light into VIBGR. When let me adjust the camera. When the white light is passed through the glass prism, dispersion of polychromatic light in the rainbow occurs. Effective wavelength depends upon the dispersive power of the prism material and the optical angles of the prism. I think so you have understood. Next, grafting. They are most efficient and efficient in conversion of polychromatic light into monochromatic light. There are mainly two types: grafting and transmission. Sorry, diffraction grafting and transmission grafting. We'll see one by one. I'll explain you the principle or the mechanism involved in it, so that you can understand it very easily. Otherwise the topics are becoming very lengthier. And guys, the main point of making giving you a lot of information is that in the master's exam they directly won't ask the instrumentation. They will ask, explain the monochromators or explain the detectors used in the UV instrumentation. Rather than explaining all the instrumentation, they will ask a particular instrument, so that I can explain in detail, so that I'm giving all the information required, so that you no need to refer other books, so that the videos are becoming this video is becoming a little bit lengthier. I think so I'll make another video where I explain the next sample holders. I'll explain in the next video. For this video I'll explain the grafting, diffraction and transmission. Grafting and transmission. Firstly we'll learn about the diffraction grafting. More refined dispersion of light is obtained by the means of diffraction grafting. The main advantage is that in more refined dispersion of light is obtained by means of diffraction grafting, consisting of large number of parallel lines, uh, 15 to 15 to 30,000 per inch in is ruled on a highly polished surface of the aluminium. To make the surface reflective, a deposit of aluminium is made on the surface. Diffraction produces reinforcement. Uh, the mechanism is the light, the ray which is incident on the grafting gets reinforced with refracted rays, and hence resulting radiation has wavelength which is governed by the equation m lambda equals to b sin I by sin r. See, we can see in this diagram there are a number of parallel lines coated with the silica, and when the light incidents, it dispersed into the uh, different ranges based upon the angle and the intensity. By this the polychromatic light is converted to monochromatic light. Polychromatic light is converted to monochromatic light. This is the basic concept. I think so I have understood the concept of behind this. And here next one is transmission grafting. It is similar to diffraction grafting, but here refraction takes place instead of reflection. That's the basic difference. Here it takes place in refraction instead of reflection. Here in this diagram there is takes here a reflection takes place, but here refraction. That's the basic concept. I think so you have between the difference between the refraction and reflection. Refraction produces reinforcement that occurs when the radiation transmitted through the grafting reinforces with the particular reflected radiation. The wavelength of radiation produced by transmission grafting can be expressed by lambda equals to d sin theta by m, where it is grafting spacing. See? Here, as the incident ray passes through the transmission grafting, the the refracted light is passes through the this layer when it does not allow the unwanted light, and it reflects back or the absorbs the unwanted radiation and only transmit the wanted radiation. This is the basic concept of this monochromators. The basic concept of monochromators is conversion of polychromatic light into the monochromatic light. That's the basic concept of monochromatic light. And this in exam you have to draw this diagram and just explain the equation and what is the principal refraction or refraction. That's the basic concept. I'll just give you the notes. You can copy the notes by pausing the video. See, you can copy this video. Guys, please subscribe so that get motivated and make a good content. Please, guys, every view and every subscribe and every like and every comment matters to me. You're watching till then means I'm so lucky. Thank you for supporting me. In 10 to 15 days, I'll complete this entire modern pharmaceutical analysis. Stay with me. Next video will start with the sample holders and we'll finish the instrumentation. Thank you guys. Bye. See you in the next video.